This is a video on the equation of a plane. The question states, find the equation of the plane that passes through the points 1, 0, negative 2, 3, 5, 1, and 4, 2, negative 1. So the strategy here is to find a normal vector and a point, because that will help us find the equation of the plane. The point, I can choose any of these 3 points. I'll end up choosing 1, 0, negative 2 for my point. So the hard part is to find the normal vector. A normal vector is orthogonal to every vector on the plane. If I can find 2 vectors that are on the plane, then I can cross those 2 vectors, and that will give me an orthogonal vector to the plane, or the normal vector. So the 2 vectors I'm going to use are the displacement vectors. I'm going to look at the displacement vector from this first point to the second point as my first vector, and the displacement vector from the first point to the third point as my second vector. So let's start out. I take the displacement vector from the first point to the second point. So I take 3 minus 1 is 2. So I get u equals 2i. 5 minus 0 is 5 plus 5j. And 1 minus negative 2 is 3, so plus 3k. And there's my first displacement vector. For the second displacement vector, I take 4 minus 1 is 3, so v equals 3i. 2 minus 0 equals 2 plus 2j, and negative 1 minus negative 2 is 1, so that gives me plus k. So there's my 2 vectors that sit on the plane. If I take the cross product of those 2 vectors, I'll arrive at the normal vector. So my normal vector n is equal to u cross v, and I set up the matrix I, j, k. U is 2, 5, 3, and v is 3, 2, 1. So now I just take this determinant by looking at I times 5 minus 6, or negative I. Then we subtract j times 2 times 1 is 2, minus 3 times 3 is 9, 2 minus 9 is negative 7, so minus negative 7j, or plus 7j. And then I have k times 2 is 4, minus 5 times 3 is 15, 4 minus 15 is negative 11, so I have minus 11k. So the normal vector is negative I plus 7j minus 11k. So the normal vector is orthogonal to any vector on the plane. So in particular, I can say that the normal vector dotted with a vector on the plane, well, if x is a point on the plane, and I subtract any point on the plane that I know, then that will give me a vector on the plane. So if I dot it with n, I should get 0. Because if the normal vector is orthogonal to a vector on the plane, that means its dot product with any vector on the plane is equal to 0. So x I'll let be x, y, z, and p I'll choose the point 1, 0, negative 2. What I get is n, which is negative 1, 7, negative 11, dotted with x minus 1, y minus 0, z minus negative 2, or z plus 2, is equal to 0. So I take the dot product, and I get negative 1 times x minus 1, which is negative x plus 1, plus 7 times y minus 0, which is just 7y, and then plus negative 11 times z plus 2, which is negative 11z minus 22, and that's equal to 0. So now I just simplify it a bit. 1 minus 22 is negative 21, and if I add 21 to both sides, then I get negative x plus 7y minus 11z is equal to 21. And that's the equation of the plane that passes through these 3 points. And I'm done with the problem.